Hi, this is Chris Schomburg, and today we're going to learn a little bit about speakers. So this lab is titled How a Speaker Works. So we're going to actually learn how a speaker works. We're going to go and explore this a lot more in a lot greater detail too. This is just a very basic start to how speakers actually work. So if we look at our lab manual, there's two things I want you to note. One, the first is that this speaker right here is different than what's in the lab manual. You'll actually be using an 8 ohm speaker, and that speaker looks a lot like this one, but this one actually is different. The speaker that you'll get actually will not have, it's non-directional. This one is a piezoelectric speaker, so it's actually a different type of design and build. And this one actually was originally used as a buzzer. You'll note that many of your fire warnings have buzzers, and they'll have piezoelectric speakers in them. The very inexpensive cameras will have piezoelectric speakers in them as well. Piezoelectric speaker has a positive and a negative value to it. Normal speakers or 8 ohm speakers will not. They can be unidirectional. In this case, we have to hook it up from positive to negative. Okay, so that's the biggest difference between this one and the one that you'll have with your kit. However, it does have a positive indication and a negative indication, so you could hook it up that way too. For this one, you might want to actually solder the leads before you put them on the breadboard. However, you could also take the wire and bend it and then curve it in and put it on that hook, and that would work as well. So both of those things will work. Okay, so let's go ahead and build this. It shouldn't take very long, and hopefully we can kind of talk a little bit more about it. But I also want to let you know that I will actually do quite a bit more with speakers. We'll probably tear apart a couple speakers and kind of analyze them, look at the tweeter and the subwoofer, which is just a high frequency, and the low frequency speaker themselves. And we'll kind of look more into what I call cool-up speakers and build speakers that we want to on our own. And that could be a project that you do at the end of the year. Okay, so here we go. We have our 9-volt battery, we have our breadboard. We have, in this case, this should be a 10 ohms, so we're going to change this to 10 ohms. Again, safety-wise, that could be a problem, but this resistor we know is at least 8 ohms, so it's going to be quite a bit of resistance between those two. So you should be fine with that. And then I actually added something here. I added a switch, and why I added the switch is because I know that when you actually use a speaker, it only works when you have an AC signal. It requires a signal that changes or is alternating. AC stands for alternating current. We need an alternating current to get this speaker to work. This is a virtual reality. It's not going to work the way that real reality does, but we'll see how it works. So first thing we're going to do, we're going to go ahead, we're going to plug in the rail. So this one is going to be our red rail. And I'm going to be really funny today, and I'm just going to hook in the black rail right next to it. Like that. Okay. Now, so the next thing that we need is we're going to actually put in a speaker. So I'm going to actually put the speaker in 1J and 1/6. Okay? And then I'm going to go ahead and I'm going to bridge this gap and actually bridge the circuit using my my resistor. So we're going to go ahead and we're bridging the gap. We're going to put that in 1F and 1D. So then I can go 1A and I can go directly. Actually, let's go one down just because it's easier to see. So I'm going to go to 2D and 2F for my resistor. And I'm going to go 2A all the way down to the red rail. Okay? So it's coming in here. That's positive. This is the positive end. We're going to bring this down then. Okay, so now we're at 2J and 7J for the speaker. Okay, so then we're going to go ahead, we're going to take the F, and in this case we're going to not use our switch, so we're going to go all the way to the black rail, and then we should see that. Now we're not having a voltage drop in here because this is the voltage drop after the resistor, and we're we're wired in through the breadboard, so we don't have to put a jumper or anything there. So let's see how this works. Okay, so it's indicating that it's actually getting sound. Now the funny thing is, in reality, when you do this, it won't actually make this noise unless if you actually touch it. And the kit actually wants you to actually touch this wire multiple times. It'll only make the buzzing sound when you touch it, and it'll probably be more like a popping sound like a radio or like a record player. Okay, for those of you who don't know what record players are, they're old style players that had waxy type of circular discs that then played music on them. I know it's not your generation, but it's interesting. So that's actually, they were originally designed by Edison, an Edison phonograph company. So let's go ahead. Let's put this in how I actually think in reality it would work. And to do that, we're going to go ahead and we're going to do a couple things. So the first thing we're going to do is we're going to put this in this switch right here in B1, 2, and 3, and I've made it vertical here. So this switch will only work, so right now it's only working between these two, terminal 1 and terminal 2, and then if we press the button, it'll be between terminal 2 and terminal 3. So that's how we want it to work. So then what we're going to do is, the common is right now going to the circuit. So we want the power to come in. We can have it either in 1 to default to start on, or we could have it in 3 to default when we press the button. So I'm going to actually do something more interesting. I'm going to go to 3 so that it only turns on once we press the button. So when we start, it should be in the off position. Then we press the button and it turns on. Okay, so that's actually pretty much exactly what how it should work in the reality. It should actually be more like a push button. So we could go one step more further. And okay, so we could go one step further and get a push button to work. Now push buttons are not easy to actually get to operate properly. So I'm going to actually just test the push button first. So here's what we're going to do. We're going to go from here, and both of those are the same terminal. So I actually think we have to rotate this. Oh, this is funny. Okay, so, alright, I'm going to delete this real quicker because I've confused myself. Okay, let's go ahead and put this right here. Okay, this is terminal 1B, this is terminal 2B. So what we really want is, this is terminal 1A, this is terminal 2A. We want it like that. So I did rotate it. Okay, so if we go here, well, this is just not designed. Maybe that'll work. Okay, so we're going to go right here. We're going to go from here to here. Okay, so this right here is red. Okay, so that's 1A. Okay, this is 2A. So then this is going to be our output. And okay, so here's what we're going to do. We're just going to test it with the LED. Remember, the flat side is negative, the round side is positive. So what we're going to do, we're going to rotate this until we have that. So this is power going in to 1A, then coming out of 2A, and then we're going to go ahead, we're going to go back to the negative rail. So to do that, I'm going to move that over, and then I'm going to draw that like that. Now, let's go ahead and turn it on. Nothing should start. If I hit this button, it does turn on. And of course it's going to burst because we don't have a resistor in there. You should always have a resistor in there, especially with the 9-volt battery. But we know that this is now working properly, right? So I'm going to stop it. Now I'm going to do the same circuit that we have up here, down here, with this guy. Okay? Now remember, if I pull this out, it's not the way we want it, because these two would actually short. So we don't want a short circuit. These are in the same line if we put it on a vertical breadboard. So what we have to do is we have to rotate it. Okay, let's see. Why is it being silly? Okay, click. There we go. Now, this is terminal A1. This is terminal AB, or 2B. Terminal A, terminal 2A, terminal 1B, terminal 2B. Okay, so now we're going to do the exact same thing that we have set up here. Red. Okay, then we're going to go ahead, we're going to copy and paste this case. The speaker. And I could put it in the same one, or I could put it a little bit later. Let's actually put it, this is funny. So if we cover that, we don't really want it covered. It's kind of in a funny placement. That's actually really where I want it. But I'm going to be silly. Okay. I'm going to put it in between here. This has nothing in it, so it's an empty line. So what I'm going to do then is then I'm going to take this right here, and I could do it like that. I really don't like the look of that though. Let's see what else I could do. Let's put it in 20 and maybe have it all by itself. And so then what I could do is something like that. That looks a little bit better. So we're going in, we're going to the push button, and then we're going to the speaker. Okay, now this is really simple. We can now go to the ground like that, and we now have the ground. So basically we're going from the 9-volt to the push button, out of the push button, to the speaker, through the speaker, to the ground. Notice this speaker, this piezoelectric speaker, has a positive and a negative end. Okay, so nothing should start with the start of the simulation. Okay, we test this. We can turn it on with the switch. We can push button and get a light. Now we should be able to push button and get a switch. Now your push button is much more like this. It's a 2-button push button. You should get one with the kit. However, it is not a 4-button push button like this one. It's more like a 2-button push button, and it should be a lot easier to use. You should be able to use that with the speaker real well, and that should get you the desired result. Okay, so we've modified this quite a bit. This is the initial one with the on and off button. That's really not how it works in reality. It works more like a push button. So then we hooked up a push button to the speaker. This is much more how it works in true reality. Again, the limitations of a virtual space versus a reality or real world application. Okay, so like I always do, I'm going to go ahead, I'm going to take a picture of this, and then I am going to go ahead and I'm going to pull out my mouse and put in my tablet. And again, this is a graphics tablet. It's what allows me to draw. As you can see, it's my graphics tablet. Okay, so, and then I have a pen. Okay, so now what we're going to do is we're going to draw the circuit schematic for this one. And I'm just going to draw the basic one. I'm not going to get into all the details of the push button and all that stuff. So basically what we're going to do is we're going to start with a battery. Oh, I didn't change the color from last time, so I'm going to go ahead. We're going to go like that. We're going to make our battery. So we have a long, we have a small, we have a long, we have a small. Okay, so this indicates a positive, this indicates a negative. And that is the symbol for our battery. I'm just going to say 9 volts. Okay, if you don't indicate it like that, it could be any voltage. So we have to indicate that it's 9 volts. So that's the same thing as this. Okay, then we're going to go ahead. We're going to assume, right here that we have our resistor. Okay, and this is actually a 10 ohm. Okay, that's to put the value on it. That's a 10 ohm resistor. Okay, the next part is not actually the symbol for what this is. This is a piezoelectric speaker. We're just doing a general speaker. So a general speaker looks like this. Okay, then we're going to go here, and then actually all we have is this line. Now, here's the reality, and here's the what's actually true. So I'm going to do this in another color. But basically, this is our symbolic symbol for what we have here. This is actually, it looks more like this. Now, the truth is that we're basically done here. We're basically drawn the symbolic symbol for what we're having here. But the key thing is that we actually have a push button right here. Okay, so we have a push button or a switch, either one, and we could actually put that in there. Now, the key thing though is that with the assembly diagram, so if we look right here, and I changed the color, let's actually go back. If we look at our assembly diagram, this is our assembly diagram. If you look at our assembly diagram, how they suggest you to do this in reality with the instructions is something like this. And then you just touch this. You take this wire and you touch this wire. It's basically like what the switch does or what the push button does. Now, let's get a little bit fancier. Now, I never remember the difference between the switch and the push button, so I'm going to actually take some time, do my homework, and we'll look at this. So what we're going to do is we're going to go ahead and go on the internet. Symbolic let's just say symbol. Or okay. So if we look at the images, the symbol for a push button switch looks like that. This is it's basically a line and a T and 2 circles. Okay? So right here, what we could do is we could go like this, T, and let's make sure I did this right. Alright. Okay, so technically, I didn't give myself a lot of space there. Okay, so let's go ahead, let's erase a little bit of this. Just make it, let's erase a little bit of this and let's make it a little bit bigger. Okay, so let's go ahead. Let's just do something like that. So we go circle, circle, and then let's look at it one more time. Okay, so we go like this. This is gonna go like that. This is gonna go like that. And then line and a T. Okay, so we're gonna go like a line right here and a T. Okay. So basically what this is, it looks like your keyboard. It's basically a switch. When you press this down, it touches both of these leads and basically presses this down. So that's actually what a 2-button switch looks like. So this is a 2-button switch, and this is actually the diagram, and that's actually perfect right there. I'm going to leave it at this. We can have a discussion later what a switch actually looks like diagram-wise and what a 4-button switch actually looks like. But in reality, this is as simple as it is. This is what you're going to do in reality. So this is the 2-button switch. This is the speaker, the 10-ohm resistor, and the 9-volt battery. All right, let's link all of these because I think it's important to link all of these to something that makes sense. So first of all, right here, this is our 9-volt battery, right? So this is linked right here to our 9-volt battery, okay? This is the positive side. This is the negative side, okay? Now, the next one we're looking at, I'm going to go with purple, okay? Now this one right here is our 10-ohm resistor. So right here, this is our 10-ohm resistor, okay? And this is our positive side, this is our negative side, this is our positive side, this is our negative side. Okay, then we're going to go ahead, let's do another color. This is right here is our speaker. Kind of even looks like a speaker. Okay, this is our speaker right here. Now notice this does have a positive side, this does have a negative side. This is a piezoelectric. Your speaker will also have a positive and a negative side. However, it's not as important that you hook it up with a positive and negative side with polarity. It is much more important when you're working with a piezoelectric speaker. Okay? So then we're going to go ahead. We're going to go to, let's actually go to more. Green's fine. Okay, then this is the push button. Now, I don't actually have a 2-button push button right here. I don't actually think I have it in Tinkercad. So what I'm going to do is just say, okay, this portion right here is your 2-button push button switch. Okay, and so technically this would be the positive side, this would be the negative side, this would be the positive side, this would be the negative side. Now no, these are different circuits. So what I'm going to do is I'm going to refer, okay, this is not perfect, but what I'm going to refer you to is this right here. This switch right here has basically a positive and let's see here. It's kind of funny. Okay, this switch right here has a positive side and a negative side right there. And this switch is functioning in the same way this switch is functioning. They have different symbolic symbols. Okay, so we'll talk about the difference in the symbols in another video. But you can see we have a symbolic symbol here, and that's actually the push button. And it's actually a 2-button push button. So let me actually draw what that would look like. So I'm going to actually say in reality, you'll see something that looks like this. Okay, so that's what it'll look like. Now if I get out my colors, this is going to be all red. Okay, it's a push button. This is going to be all black. Okay, we're going to have a black end, and we're going to have a red end. And then we're going to have copper. which, let's say that's copper on either end. Okay, so in reality, this is the device that will be positive and minus, and that's the device that you'll use here. Okay, so in reality, this device would go right here. Okay, or if we're looking at the circuit that's in place right here, we would have it right here. Okay, so hopefully that's not too confusing. Again, with Tinkercad, I don't think I can do two button push button switch, but I did do a 4-button, and then I did also a slide switch. Okay, so we'll look at the symbols of those later, but hopefully you've understood a little bit about speakers. We'll do quite a bit more with speakers in the future. Again, that's all dependent on kind of choice and voice that you make as students, but I have many speakers that we can tear apart, look at the insides of them, and actually really kind of tear them apart. And then also build maybe some cool speakers or some bigger speakers with the parts. Okay, so looking forward to that. So please view more of these videos later to see more about that coming in the future.